A bell curve or a normal curve describe the distribution of a set of data that creates a bell shape, and it's usually used in statistics. You will use it to examine a set of data that you have gathered. What is our probability and its certain characteristic. So let's go talk about those characteristics. The first one is the center of the curve is the mean. Mean is always in the center, right? Then median, mean, and mode are all equal. A bell curve has one mode, so there's only one peak in a curve. One peak is called unimodal. The curve is asymptotic, approaching given value or condition as a variable, or an expression containing a variable approaches a limit. No matter what we are measuring on a normal curve, it will be height, weights, middle, altitude. Your eyes going to see this symmetrical shape. So, the last characteristic.
Good day everyone. Our group will present to you the basics of the normal distribution. But before that, let me discuss to you what should we know, the bridge of the last lesson for today's topic. Histogram and other graphs such as pie and line play a big role on data analysis of probabilities of random variables, either discrete or continuous. Another tool to describe this data is the normal distribution described by a bell-shaped curve. This will easily help you on how the data affects each other and spread into one another.
A normal distribution has a single mode or unimodal as shown by its one peak hump. Distribution as a center value or the mean. It also has a computed average or mean from the given values. A normal distribution is symmetrical at the mean, meaning the normal curve appears to be equally distributed from the left and right side. It will appear as a bell-shaped curve.
Hello everyone, I'm Kenjie Aronda, and I will discuss the properties of the normal distribution.
Number 4. This is the normal curve, and this is the center of the normal curve, and it extends to the left and right sides away from the center.
Number 5. The height of the normal curve, or the perpendicular distance from the x-axis, is maximum at the center and decreases as you move farther away. This height never becomes zero, thus the normal curve never touches or crosses the x-axis. Number 6. In a normal distribution, the mean, median, and mode are all equal. We all know that the mean is in the middle of the distribution, right under the peak of the curve. And in the median, it is the score positioned in the middle of the dataset, and it is ordered from smallest to largest. In normal distribution, all the scores are already ordered from smallest to largest. If I draw a line in the center of the curve, we have a mirror images and same scores either sides, which means that the median is in the middle of the distribution as well.
Since the normal distribution is continuous or it is measurable, the probability is expressed area under the curve based on the boundary specified. Thus, the area or the total area under the curve is always equal to 1 or 100%. Here are the examples. And because of that, we therefore have 4 possibilities or 4 possible shaded areas that we could encounter in our study of the normal distribution. Here are some examples of using normal curve. which are centered 60 minutes. The text in the image describes how each is presented or represented mathematically. Then we use x as symbol of our random variable, as well as some phrases that denote the given shaded region. It is very helpful to be familiarized with this for ease of solving word problems. And remember that the area of the shaded region denotes the probability. Based on the picture, we must remember that there has to be specified interval or bounded region for us to obtain the probability. This is true for continuous random variable. Likewise, if we are asked for the probability of x being exactly equal to 70, or p, x is equal to 70, the answer is 0 because there has no area. Ooh, I'm not done yet. Sorry. So the size of the area within the one standard deviation away from the mean is approximately 68%, and the size with the area within the two standard deviation away from the mean is approximately 95%. While the last one, the size of the area within the three standard deviation away from the mean is approximately 99% or 99.7%. This is referred to as the empirical rule, or so-called 68, 95, 99.7 rule. This is true for any normal distribution. The shape of the normal distribution depends on only two values, the mean mu and the standard deviation sigma. It affects the shape by means of changing its value if it is increased or decreased. The mean only changes horizontally where the center or the mean was placed before or originally, while in the standard deviation, it changes the height of the graph. It is either the graph reaches a higher peak if the standard deviation sigma decrease depending on the original or its initial value, or narrows the graph which has increased standard deviation sigma. Here we have a mean of 0 and have a sigma of 1, and the mean is located at the origin of the coordinate. And if we change the value to 1, notice the changes of the location of the curve. It changes, right? Right. Yes, it moves to the right. If I reduce the mean to 0, notice the change. It turns back. So, the mean is only affected at horizontal axis, which is not affected, which it can't affect the height of the curve. We have sigma here, 1. This is the standard deviation. If we increase this to 1.25, notice the change of the height of the graph, it narrows. Yes, it widens. If the changes of 1.5, notice the change of the sigma. When it comes to the increase of sigma, it will narrows the graph. But if I decrease it, it will reaches to the highest peak or higher peak of the graph. Standard deviation is the measure of the spread. Yeah. Here is a picture showing a few normal curves with the various means and standard deviations on the same plane and scale for comparison. Therefore, there are infinitely many bell-shaped curves, as many as number of possible pairings of the mean and standard deviation. If you graph your data and it looks like somewhat similar to a bell shape, there is a chance that you could use normal distribution to model your data. Test of normality may be conducted to verify this more accurately. However, these will be covered when you to your higher studies in this subject. Most of the data we will consider will be normal or assumed to be normal unless otherwise stated. The mean can take any value of the random variable, while the standard deviation cannot be less than 0. Also, probabilities cannot be negative.
This is a quick recap before we end. Give me a beat, yo! So, now you learn what a normal distribution looks like and why it is important. Furthermore, you gain knowledge about the 3 different kinds of average, mean, mode, and median. You learn about the range integral or range variance standard variation. Lastly, we all know the normal distribution is a probability function that describes how the values of variables are distributed. For me, a normal distribution is the most important probability distribution in statistics because it fits a many natural phenomena. For example, height, blood pressure, measurements, error, IQ scores, and many more. I hope you learned a lot from us. Thank you for your watching. Yo, 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 yo.